We're on right now. All right, everyone, we're going to get started shortly. I'm going to adjust until we get started. All right. Greg. Cool. Yeah, also quiet the room. That's awesome. All right. Wait, can you guys actually talk? Also quiet the room. That's awesome. Oh, I'm hearing myself. All right. Wait, can you guys actually talk? Myself. Oh, I'm hearing myself. Okay, hey, thanks everyone for coming to the first Denver Data Engineering Meetup. We had 150 people join the group before our first meetup, so I think that's a pretty impressive number. 60 people RSVP'd to this. It was a little rainy today, so I think probably some people stayed home. But we're recording this for any of your friends who couldn't make it, and we'll be posting the slides after the meetup, so you can review them or get in contact with anyone that you meet here. So we're going to have two talks tonight. The first is Greg Neiheisel, who'll be giving Apache Airflow at scale. He'll be doing a little rough rundown of what Airflow is, why you would use it, who is using it currently at scale, and some of his experiences using it in a few different setups. We'll also have Marta from Confluent talk a little about Confluent and Kafka. If you don't know what Kafka is, you definitely should. So you will by the end of the night. So last of all, I want to do a quick thanks to the people who have made this possible. Astronomer and Confluent for paying for beer, soda, pizza. There's plenty left. Well, like I said, we'll have, actually, thank you. Proper thanks. We will have a break between the talks, so if you want more pizza and you're like, oh, should I go out there and get some more? And there'll be a break, so don't worry about that. And I'll probably offer it to them, because it's way too much pizza anyway. Lastly, I want to thank Galvanize. Technically, we do have to thank them because we're using their space and it's in our contract. But I would thank them anyway, because they're very generous and they're leading a great conversation around data. They have some great data science programs. If you're interested in being a data scientist, I would definitely recommend looking into Immersive. So without further ado, I'll give it to Greg to talk about Apache Airflow at scale.
Thank you, Ben. So I'm Greg Neiheisel, CTO at Astronomer. We are a company based out of Cincinnati. We have various, a handful of different kind of data engineering related products. But the biggest one we want to talk about today is kind of our experience through what we've done with Apache Airflow and kind of how we've evolved.
Live stream issues. Sorry, continue.
Go ahead. Well, now I can't. So just talking about the experiences we've had deploying and running managed Airflow for our customers.
All right. We have people watching, telling us,
good.
So sorry.
Cool. So, like I said, one of our products that we do offer our customers is a managed Airflow service that can be. We run a cloud version of this that you can just sign up on our app and boom, you got an Airflow instance up and running. We also deploy it to our customers' clouds, whether they live on Google, Amazon, VMware, Azure. So just going through some of these experiences as we go. So just show of hands, who here has ever used cron? Thrown a cron job out on the server, hoped it worked forever, and it probably didn't. I have. Yes. Cool. So so who here has used Airflow? Anyone used Airflow already? So I talked to a couple people. Cool. A little less. So there's a lot of stuff coming out these days. Airflow. I don't know, how long has Airflow been around? A couple years, 2-3 years now, since it's kind of since it's been incepted at Airbnb. Really, a lot of people are kind of taking it as the next step from cron. So say, hey, cron has failed me before, doesn't really do a whole lot for me. We need something else. So people are kind of moving toward looking for something else. If you've been in the big data, ecosystem for a while, and you may have used different task schedulers, Uzi, Azkaban, there's others, Luigi. Airflow is kind of the one that's kind of standing out from the crowd and kind of taking off, where the others are kind of dwindling a little bit. So what is Apache Airflow? One way to talk about it is it's cron on steroids. But I don't think that does it justice. So what it really is a task scheduler written in Python to programmatically author, schedule, and monitor dependency-driven workflows. We'll dig into what that really means here a little bit. It's also incubating in the Apache Foundation right now. 7,500 stars, 4,000 commits, 400 contributors. And it's growing. There's a lot of big companies kind of jumping on the bandwagon and hoping bring it, make it a great project. So no doubt that it will become an official top-level Apache project pretty soon here. So big companies using it. You may have heard a few of these: Airbnb, Uber, Slack, a couple more. The project was actually started at Airbnb. It kind of was, one of their guys came from Facebook, had some prior knowledge of a system they built there called Data Swarm, kind of a closed source system. He took it to Airbnb and pretty much recreated it from the ground up, called it Airflow. So what are the a couple use cases? Why would you use Apache Airflow? Biggest use case, one of the biggest ones is just traditional ETL, whether you're pulling data from a database into another database, or pulling data from APIs into your database, syncing data from different sources into a common sink, data warehouse, data mart, that kind of thing. It's also used a lot for taking raw data that may live in maybe a data mart, some kind of raw structure in a database or an analytical database, and kind of building up into the actual data warehouse, the core tables, the tables you run dashboards on, tables you run, you pretty much run your business on. Newer use cases, obviously machine learning's becoming a huge thing. So model training is becoming a big use case for Airflow. And then notification system here. You can use it, part of, what it does, it lets you kind of tap into these notification systems, but really you can use it to do, maybe data quality checks, data governance kind of checks, that kind of stuff, like, make sure that everything looks right, and then send notifications if something looks off. So the core, pretty much everything in Airflow is kind of centered around a DAG. I'm tired of saying the word DAG. We say the word DAG, millions of times. It kind of lost its meaning. But DAG is, you're not familiar, it's a directed acyclic graph. What that means is just that you can set up task dependencies, and they can only go forward. You can only move forward in this graph. There's no looping around. There's no going backwards. You progress through the graph until the end, until you've executed everything. So this is an older screenshot of Airflow we pulled from the website, but this is what that DAG actually looks like within the context of Airflow. This is a pretty complicated looking DAG. Not quite sure what it's actually doing, but something very important at Airbnb, I'm sure. But that's kind of what it looks like in practice. So just kind of jumping into how you work with Airflow, what are the different components of Airflow. The first thing is what Airflow calls operators. So operators are how you get something done in Airflow. So operators are, if the DAG describes how to do, a workflow, the operators are the things that actually do the work, do something. There's a lot of different types of operators. One type is sensors. So sensors are kind of ways to, run a probe, kind of check if something exists. So if you've, if you're dealing with, I know one thing we've dealt with in the past is like FTP. some third party has to drop a file on an FTP server, and probably half the time it works, half the time it's there on time, maybe it's not. You can use something like a sensor to kind of check, hey, does this file exist? And there's built-in sensors into Airflow. All these operators right here that are listed are kind of built into the core Airflow. So S3 key sensor, something like that, just pings, says, hey, does this key exist in S3? And then if it does, you can kind of take an action. You can proceed with the graph. You can proceed down this branch of a DAG, or you can choose to skip it. Hey, the file's not there, not a big deal. We'll deal with it later. You can kind of, you have this kind of semantics when working with Airflow. So there's all kinds of sensors. Some of these, what we call action operators here, just a different type of operator that just, you can do something. It's, you can run an R script, or run a Python script, or run a, just anything you want to do. So the bash operator is kind of like, it's kind of like the way out. You can always run something through a bash operator. It's like you can just shell out something that you need to do. So you can kind of, a lot of times we see people using the bash operators taking maybe legacy things that they've already written, things that they've already had written as a cron job, or just running manually some kind of external trigger, however they were triggering it before, or running it before. If it's not in Python, you can just kind of use the bash operator to kind of just shell that thing out and get whatever that thing is trying to do done. Python operator, you can pretty much just write a Python callable, just a function, and it'll run the, that's pretty self-explanatory. Just run a Python function. Email operator is another example. A big one for us, we do a lot of ETL stuff. So these are not official terms, the action and transfer. We just kind of made those up. But a lot of the operators take data from somewhere and kind of either transform it, do some kind of processing, and then dump it somewhere else. So S3 to Redshift's a big one for us. We kind of grew up on the Amazon cloud, so we deal with a lot of the Amazon data stack. But you could take data, pull data from S3 or Salesforce or something, write a DAG that goes out, grabs a bunch of data from S3, or checks diffs, what you have from Salesforce, pull it to S3, and then do something with it. But yeah, so operators kind of describe, or they describe what's actually happening in that node of the graph. Hooks are another concept within Airflow that they kind of, they're the hook to an external system. So a lot of times, a lot of the use cases are ETL. You're often going out, grabbing data from some external system, and processing it into something else. Common hooks are just GitHub hook, Slack, S3, Postgres, Druid, anything you could ever try and access data from. You would pretty much model that as a hook in Airflow, and it's just a common interface. So the core Airflow just defines, this is what a hook looks like. Just define these methods in this Python code, and then plug it in, and it'll operate as a hook, and the system will recognize it and work with it. So you pretty much take hooks, combine them into an operator, and get something done. Those are kind of like the two core. When you're programming an Airflow DAG, those are kind of like the two things you work with a lot. Another big reason that I think Airflow has taken off is that it has a concept of plugins. It lets you take what you've written and reuse it other places. Like any good system would let you do. So a couple cool things you can do with it. You can extend the Airflow API. So Airflow exposes an API that its web server and components use. You can define new methods and different API endpoints in there. You can actually define new different views and dashboards if you have something. We haven't done that a whole lot, but I think there's some good use cases we can kind of dive into in a little bit here. Just package hooks and operators. We do that. We have a whole GitHub organization that we kind of maintain right now. It's just people are just throwing Airflow plugins into, and we're just kind of curating them for the community. All right, so this is kind of what Airflow looks like. You know, if you've defined a DAG, and you've given it some kind of trigger, usually you do a cron tab syntax, and you say, I want this thing to run every hour, I want it to run every day, every 15 minutes, that kind of thing. You can do any kind of cron tab syntax, but you can also do external triggers. It's not a big use case that we've run into a lot, but you know, totally possible. So if you've defined a DAG that defines how a workflow should proceed, a DAG run is what Airflow calls the actual instance. So if I have something that needs to run at midnight every day, that instance that runs is called a DAG run. And this is kind of a little view of some DAG runs that we took from one of our systems. Task instances, kind of like very similar to DAG runs. It's one of the nodes in the graph. So as those tasks are executing, as Airflow moves through the graph, those are called task instances. So if you have we have here is like a clickstream to Redshift. So what that is like it's taking data from S3, taking a bunch of clickstream data that we've accumulated on S3 throughout the hour, and it's going to actually move it to S3, dump it into Redshift. So each node in that graph, as it's running, creates a task instance. Here's just another view of Airflow, just kind of the graph view. So we're looking at a DAG here. This is one of those the clickstream to Redshift, a little deeper. You can just kind of see how the graph view of these things looks within Redshift. This is another view within Airflow. It's the tree view, so you can actually see the task instances across time. So this is kind of useful when you kind of scale things out in some ways. So when you're running locally, you kind of just have it. You have it in the very a non-parallel, non-concurrent running. Just kind of like test things out. When you deploy it to production, you can define some semantics around the way that the DAG actually runs, and if you can, maybe you can say like, I want. It's cool if multiple of these DAG runs run at once, like that's fine. Or you can say, hey, no, like every single DAG run, it has to. It's like a linear, like it can't run unless the previous one ran and went successfully. So this can kind of give you a view of like how it's performing over multiple DAG runs. But there's a problem. So as you're scaling, this is kind of a scaling problem. So if thousands of tasks are running every day with conflicting package dependencies and different resource requirements, how do you scale that? That's something that we've had to figure out. We've tried a lot of different things in this to answer this question. So this is where the idea of executors comes in. So this is another core Airflow concept, just like everything else we've talked about. These executors. So executors they can be defined as a plugin as well. It's just Python code under the hood. But really, it defines. You write executors to say, hey, where do these tasks run? I have a task. I have something to do. I have some unit of work to do. Who's going to do that? Who's going to do that, and where is it going to happen? So that's kind of where executors help you out. Airflow comes with a couple of them built in. Sequential executor, it's a built-in one. It executes one task at a time. It's really only meant for testing. When you really want to like make sure that something's working properly, in the proper sequence and all that kind of stuff. That's when you use that. But there's no other reason to actually use that in production. Then it has this local executor. So it's another built-in. It's been around forever. It's been in Airflow since the beginning, but it is multi-threaded. So as tasks are happening, if different tasks can run concurrently or in parallel, or different multiple DAG runs can be happening at the same time, you can use the local executor. The local executor will multi-thread, and as tasks are up to run, thread them out, run them on one machine. Though that's the key. Is like the local executor will only run on one machine. But I mean, that's not a horrible thing. We've talked to a couple companies who are running Airflow in production with a local executor. They just have one big old EC2 instance or whatever, out there, and everything they need to do can get done on that box, whether it's actually happening on that one box, or maybe their DAGs delegate all their work out to external systems. So if they're running, big SQL query, that's not really running on that machine. That's running out on the database. So not a whole lot of resources needed in the actual box. So depending on use cases, that may or may not work for you. The next one is this Celery executor. So it's another built-in executor. It's I don't know if anyone's heard of Celery, but it's a Python. It's a Python task queue. It's been around for a while. Pretty solid. A lot of different use cases. Really, if you're using the Celery executor, you need a RabbitMQ or a Redis instance kind of backing that queue. There's a couple other options that are kind of experimental, like SQS or a couple other things. Rabbit and Redis are the big ones. We run everything in containers. So we're only a couple years old, so we kind of were born right into this cloud native this world. The way that Celery works is that you launch a worker on different nodes potentially, and that worker can take tasks off the queue that the Airflow scheduler kicks onto that queue. Feels a little weird in a Docker in a containerized world, because you launch Celery, the worker kind of in the foreground, and then it kind of forks off processes and for the tasks, and that's just it's kind of like it goes against what Docker kind of stands for and the containerization. It should really just be containerizing a single process. This is kind of the way it was meant to run. So that kind of feels weird. It works. It works fine. You could run it on an EC2 box, just on the host, or you could run it in a containerized system. We run our enterprise edition right now. The enterprise edition that we work with, or we distribute to customers. We use this. So we deploy to Kubernetes. We launch workers. We launch Celery workers in containers, and they work just fine. So just something to think about. So I'm just going to skip ahead a little bit here. This is kind of what that looks like on Kubernetes. So not everything has to be running on Kubernetes. You could, like I said, you could just run this on. You could just spin up EC2 boxes and SSHN and figure things out. But this is what it kind of looks like in our Kubernetes world. A lot of stuff we're not showing here, but this is kind of what Airflow looks like. So you have a multi-tenant environment. So we run a cloud version of this where multiple people come in and they log into our system and they say, hey, I want an Airflow. Customers can do that. So every time a customer requests an Airflow instance on us, we launch a couple things out there. We launch an Airflow worker, or we launch an Airflow web server and an Airflow scheduler. So two things there. So the web server obviously shows that UI that we've been looking at. It's a Flask app that it's all right. And then there's the scheduler, which is really the meat of what Airflow is. So this is it's pretty much in a constant loop, checking dependencies in a database. So we use it typically with Postgres. You can use anything that SQL Alchemy works with in Python. So MySQL is another big one. But that scheduler is really just looking at your DAGs and saying, hey, I need to run something, or I need to run these tasks. I'm going to make these task instances, and I'm going to put them in the database, and then launch them out into these Celery queues. And we run these workers. So in Kubernetes, what this looks like for us is we run, people are familiar with Kubernetes lingo, we run a stateful set for these workers, which just means they get a stable host name and a stable, or they get a volume that can be mounted, and that can be persisted through restarts and things like that. So what that gets us is that pretty much just works out of the box. So we just pretty much say, hey, we want to work, we didn't have to do any hacks or any mods or anything like that. We just say, we're using the Celery executor, and the Airflow UI knows where to go find the logs and everything. It all just works with a stateful set. So it's pretty beautiful. So yeah, as I mentioned, like, one of the things that we have to worry about, Airflow, I don't have a screenshot of this, but if you've used Airflow before, you've seen it. You click into a task, if you click into that graph is actually clickable. You can click on a node in that graph and you get a bunch of options, and you can click into the logs. So if you get a failure, or if you're just debugging, you just want to see what the hell's going on out there, you can click into that node and actually view the logs in real time as they're streaming through. So as your tasks are executing out in a distributed system, you can kind of get the logs and look at it. And with Celery on Kubernetes and the stateful set, that just worked out of the box. So it's pretty beautiful. So stepping back for us, we've also used the Mesos executor. So this is one that's community contributed. It's not kind of, someone just wrote it and threw it in there, got a commit in, and it's just kind of been sitting there for a while. When we got started, Kubernetes was kind of newer, and we said, hey, let's see what it looks like to run every task in a container. So as tasks come up, as Airflow has to run tasks, what if we just ran every single task in its own container instead of spawning multiple processes? It's kind of like more like the cloud native way to kind of do these things. Problem with that is that it requires a Mesos cluster, and it's pretty heavy. It's a pretty heavy requirement. I don't know. Does anyone here use Mesos or play with it? Yeah, not a whole lot of people. So it's a heavyweight thing. You got to really be bought into it already for that to be something that's attractive. So we've kind of steered away from it a little bit. The initial implementation, the implementation that exists in Airflow right now in the repo is not even containerized. We had to do some modifications to get, not a whole lot of modifications, but we just got it to Dockerize and just run things on the containers on the hosts. And we removed pickling. So pickling, if you're unfamiliar, pickling is just it's object serialization in Python. So what that got it was the Airflow code that you've deployed didn't really have to be on the worker nodes to actually run the tasks. It could kind of hack around that by storing these objects in the database and then unpickling them when a task was running. And pickling is just a disaster. We kind of banned it. We kind of banned the word pickle from our lingo at work. So we got rid of that. So what we did to get around that was pretty cool, and we're still using this method today. Is that, we really just pack whenever we're running a task in a container. We really just pack the whole code. So the same code that's packaged inside the container that's running your scheduler and your web server, we just run the same container. We run the same image, and we just run your tasks in them, and then your code's there. You don't have to pickle. You don't have to deal with that. It's a lot better. The upside is that containerization. The containerization aspect of this thing felt right. That's about all it got us, and it's still not fully implemented. We never got around to fully implementing this thing. There's just when you're writing an executor, there's a couple of things you got to juggle around, and we just the one that exists in Airflow right now is not fully implemented, and we never got around to fully implementing it. It's just programming against Mesos is it's a little bit of an effort. So early on in Astronomer's life, we kind of ran this kind of super Airflow behind the scenes, and we let people kind of say, hey, I want data from X to Y, and we would kind of dynamically generate a DAG behind the scenes. They had no idea Airflow was a part of this thing, and we would just run the tasks behind the scenes. So we just had this giant Airflow for all kinds of customers doing all kinds of things. And it just, like I said, just ran the task. We would launch. We had one scheduler, one web server, and we pumped the logs to S3, which is a downside in itself. Airflow has an integration to pump the logs to S3 to kind of be its backing store. The downside is that sometimes tasks fail and the logs don't get uploaded, and even if they do get uploaded, it's after the task is already run and finished. So if you're trying to debug a long-running task, sorry, yeah.
So when you say pump, well, like what's doing the pumping? Like Airflow is directing something to do it, right? It's not clear doing it. It's just
yes. Yeah, so like pumping the logs to S3, yeah. So I mean, it's just, all it does is when a task runs on, we would run it on a, in this environment, we were running every single task in a container. At the end of that task run, it would just load, it would just literally just take everything that is logged out and just upload a file to S3. And like I said, downsides of that are logs don't show up. If you click on the UI for a long-running task, it's going to say no logs found until the task finishes, which is kind of lame. Sometimes I haven't experienced this, but I've heard that sometimes the tasks can fail and then the log upload fails. So it's kind of like you have tasks failing and now you have no idea why they're failing. So it's just like, kind of weird, not good. So after that, we launched a kind of a multi-tenant on the same kind of idea, where we really just, users would come to our app, they would sign up, say, hey, I want an Airflow. We would deploy the core components, the web server, the scheduler, launch them out there, and then, those individual schedulers, so you can imagine like, 10, 20 schedulers out there on this cluster, all scheduling tasks. That's pretty much what this was. So every single scheduler registered itself as a Mesos framework and would communicate with Mesos, take resource offers from the nodes, and then schedule tasks out onto these nodes. Like I said, the executor was kind of unfinished. It's kind of in a half-built state. So there's a couple things in there that so it got hard to track a couple things. Things got hard to trace down. So we're moving past that now. So like I said, we run for our production environments now, we run Celery on Kubernetes, the Celery executor on Kubernetes. Just recently, there's someone at Bloomberg, Daniel at Bloomberg, one of the Daniels at Bloomberg, I'm sure. He wrote, he's been working on the actual, like a Kubernetes native executor for about, I'd say, about the last year. I think the PR was originally opened last June, and it just got merged to master last week. So similar, I think it's very similar to the Mesos executor and vision and what it's trying to accomplish. Every single task runs in its own container, very similar to the Mesos thing. The big difference is that it's fully built out. So everything that you would want out of an executor is more or less in there now. I think a very important piece of what this executor has been written to do is when it launches a pod. So if you're familiar with Kubernetes lingo, a pod is a group of co-located containers. So say you launch 2 containers, both of those containers in that pod run on the same host, and that's what a pod is. And they can share volumes and they can share some other things. But when a task is launched, that pod gets picked up, says, hey, it makes a request to the Kubernetes API and says, hey, I need to run a pod with this task. Here's the Airflow command that I need to run in this image. That works beautifully. That's not too hard to accomplish. The cool thing is that it subscribes to the Kubernetes watch API. So the executor actually spawns out a sub-process that's kind of always listening for events, and Kubernetes is pushing events back. It's subscribed to an event stream from Kubernetes. So when pods succeed, when the task is successful and it runs, you get a notification back, and you can say, "Hey, Airflow, this task is good. Mark it as green. Proceed down the graph." If a task fails, if it throws an exception, whatever, task fails, the pod will fail, and then we get that same notification says, "Hey, this thing failed." So, hey, Airflow, this task failed. Let's retry it, in a couple minutes. However you define your DAG to do. However you would find that retry policy. So that's really cool. The other cool thing is that it resubscribes. So if the scheduler goes down, if the scheduler crashes, if the scheduler gets a node goes down, you lose a node in your cluster, your scheduler, those pods, that scheduler pod will get rescheduled to another node and spin back up. Well, it keeps track of where it left off in that event stream. So while that scheduler was down, tasks finished or tasks failed or succeeded, it resubscribes where it left off and gets that event stream, and then goes ahead and pretty much updates itself, syncs its state with Airflow, which is really good. And I think that was pretty poorly implemented in the Mesos executor. So this is great to see for us. A couple other cool things about this executor. It has an optional init container that can pull code from a Git repo. So I think a pretty common method of operation these days, or right now, with people using this executor, the community is, push your code up to a, be continuously, pushing, just like any kind of software project, push code updates to your Git repo. And then every time a pod launches, every time a worker launches one of those pods that is running a task, it will fire off an init container that is shares volume, shares a volume with the actual worker container. Pretty much just does a git pull or git clone. I forget which one. Probably just does a full clone of whatever repo you have configured, and then the code's there. So there's no pickling. There's none of that stuff involved. This is kind of the way to distribute code in a distributed system like this. And then the task logs, like I said, that's kind of a concern when you're running Airflow in a distributed environment like this. Kind of, you have to think about how you want the task logs to work. So it's a separate concern. This executor doesn't do anything about it, which is fine. We can work around that. So we're working on some enhancements, or some. I think we're going to send a couple PRs to Airflow pretty soon here. Just to kind of introduce a little different way of operating. So in our system, we run a little bit different. Our users use our CLI. We have a CLI tool that they use to build their Docker images with their code. So when they're working with DAGs locally, and they want to package those up to push out to production, they use either a CLI command, or they integrate with like a continuous delivery kind of pipeline where they push their code to Git, triggers a Docker build somewhere in there, run tests, trigger a Docker build, and they push it to our internal registries. We run a Docker registry. So one way or another, that image has to get pushed to that registry. That registry receives the new image, calls a webhook, and then we update the containers that are currently running on Kubernetes with the new image. So that scheduler and web server out there running with the last version, we nuke those two things, and then bring up the two new ones with the new version of the code. So we don't really need to do any Git pooling or cloning like that. The code is just there. We run all the tasks, any kind of container that's running in this system already has the code. So we're going to send a little PR right now, because right now if you try and do something like that, it yells at you. I think we're just going to kind of. I just commented that part out right now, so I got to work on the real PR now. So, but it shouldn't be too tough. So the way we manage logs. So like I said, as you're running these tasks, Airflow just logs out to a log file. It's not spitting the task logs out to standard error. It's really it's running a log file and at a path that corresponds to the task that's running. So the DAG run, the DAG ID, task ID, the try number. So if this is my 5th try on this task, that's part of that. That's part of that file path. So what we're doing, or what we're experimenting with right now, is running a sidecar container in that pod. So every task that gets launched in a pod, we launch a little container that literally just runs a tail. It just runs tail, and it follows the file. So it looks at that file, and it spits all the logs out to standard out. And then Kubernetes from there kind of takes those logs from standard out from all the containers and funnels them back to the hosts under like varlib or varlog containers, something like that. Some well-known path on the host. And then we have a Fluent daemon set that runs on every node. So a daemon set is just, you tell Kubernetes, hey, I want to run a daemon set. It'll run an instance of that container or that pod on every single node in your cluster, or a subset if you want to specify like a node pool. That thing is tailing those logs. So we have a sidecar container tailing the logs from the worker down to the host. Fluentd is tailing those logs and shipping them off to Elasticsearch, which is also deployed. We use Helm. Helm is a package manager for Kubernetes. There's a nice package out there for Elasticsearch. Pretty much just picked that thing up and ran with it, just deployed it to the cluster. Pretty much just worked. So it launched, that Helm chart launched it launches Elasticsearch and Kibana. And then we launched the Fluentd daemon set to watch those logs. The Elasticsearch log handler is another like recent commit. I think it was merged 2 weeks ago. So these are two commits: the Kubernetes executor and the Elasticsearch log handler are very, very fresh on master. They're not released yet, so very new. So there's some tweaks we're kind of working around that too.
I'm from Elastic.
Oh, great. Well, I have had no problems with Elasticsearch, so I think that worked perfectly. So great job. This is kind of what that looks like. These are very crude diagrams I just whipped up like 20 minutes before this thing. So, very similar. You have the Fluentd daemon set there. You can see that it runs on every node. And then I'm really only showing one instance, but if there's, it's running Elasticsearch out there. Just, it runs right now. I just have 3 pods, kind of running 3 nodes of Elasticsearch. And then there's more components in Elasticsearch. Who knows? But I'm not showing them. Just launched the web server, the scheduler, standard, launch them out on containers, and then the tasks actually get executed in their own pods. And then that whole system, like I just described, kind of just works. And one cool thing about the Elasticsearch log handler that was just committed is that it's a little different than it's a little different than the standard log handlers in Airflow, in that it has like a continuous scroll thing. So like you can just keep scrolling, like the logs keep refreshing. It's not that crazy in today's world, but for Airflow, it's pretty cool. So it's new. So I mean, that's kind of our journey through Airflow. A lot of the stuff that we've done. A couple of things we're working on. Airflow podcast. Subscribe to that. We got we've had a couple of interviews with a lot of the core committers on Airflow. So a lot of good content there. And then like I mentioned earlier, this Airflow plugins org that we're running on GitHub. Ben's doing a lot of that work, just curating a bunch of plugins. A bunch of people are kind of jumping in on that recently. So if you need to write an Airflow DAG and you can't find an operator or a hook, check there. It might be there. So that's it. Any questions? Comments, questions?
What else does Elasticsearch do?
I don't know. You want to step up? A lot of great stuff. I don't know. I haven't messed with a whole lot out of this context, so it's kind of new for me. I love the new Kibana, by the way. The new UI looks great. Yeah.
What do you do to keep your users from hurting themselves? A lot of cases Airflow where you can really get yourself into a terrible situation.
Yeah.
It's very easy to deadlock Airflow.
Yeah.
How do you keep them from doing that?
Yeah. I mean, not doing a whole lot around that specific issue right now. I mean, what we're trying to do, I think, the big things that we're trying to tackle as a company, things that we're trying to lower the barrier to entry to Airflow. So it's like a no-brainer. You click a button, you got a distributed environment that you don't have to think about. We're working on ways to get like the schedule. I was just talking to Ben earlier, like getting the scheduler logs. Big thing is like you it works cool on your machine, right? Classic, engineer, like it works great, deployed to production, and it bombs out for some reason or another. Maybe a missing, in the Airflow world, it could be a missing connection or a variable or something that's you have in your development environment but doesn't exist in the prod environment.
I once got the scheduler caught in like a crash loop because I didn't have a resource pool set. Like so only 2 tasks could access this one database at once, so it was like resource pools 2. But I had it locally, not on the scheduler in cloud. When I pushed it up, it just like crashed the scheduler, which then tried to start back up, which then crashed. It's got caught in that loop, and you can't debug it because it's crashing.
So I mean that's we're trying to make it super easy to like discover those problems through the logs at first, and then maybe we start building some guardrails on what we can do around that. But
how do you move your, say, large binary blobs of data between tasks in Airflow? Are you sort of moving it over the network, or it sounds like the output of each task is putting into a database that says, great, task complete, and then that output becomes available to downstream tasks?
Yeah.
And also, as you said, in terms of scaling, so what if that output is like a 3 GB file or something?
Yeah. There's a couple different, it really depends on the systems like you're interfacing with. If there's a way to kind of transfer a blob of data from system A to system B without sucking it through, your Airflow worker.
Yeah.
Like if your Airflow worker just like issues a command and says like, we do this with Redshift. Redshift's a good example. Or we load a bunch of data to, I don't know if you loaded data from S3 to Redshift. You can pretty much just issue a copy command and just point to the S3 files. So in that sense, like you're moving data from S3 to Redshift, it's not actually passing through the Airflow worker. It's really just ran a SQL command. But there's a lot of use cases where that's not a feasible solution. So you do have to suck the data kind of through your worker.
Because you don't have a shared file system. You can use a volume, I guess.
Yeah, and that's kind of that gets a little trickier in the containerized world. But if you run like the local executor or something like that, just on a beefy box, then you could suck a file in right to the host file system and then pick it up and work with it. I think we're really pushing to just be fully containerized. We may be able to build solutions around that using Kubernetes. The stateful set or just persistent volumes in Kubernetes. So maybe we build some stuff around that lets you, treat every worker as if it's on the same host, but in reality they're, running on completely different hosts. I think there's a lot of stuff we could experiment with that for sure.
All right, thank you guys. All right, I think let's take a 5-minute break, bathroom break, soda, beer, or pizza, and then we'll back to Martin. Hey, stop from that side. Not wearing we just have a really nice staging environment process that relies on Yeah, I mean, that's the reality. We don't like reshoots. Yeah, no one does it. Like seriously, Team McQueary, you're like, no, that's a hard no. Seriously? Yeah. Sorry. I'm literally not
I'm not looking sure.
Okay. So I guess the one thing, this is sort of outside. But you guys are bought out of the WMS interface, right? the maps are sort of pretty, I mean, we're getting them to talk about the tab model, that's standard. Geo, basically a standard geo reference file, which has basically the name of the JPEG image, and then 4 coordinates that are mapped to actual GPS coordinates. So you can actually overlay it onto your video, right, where it is exactly mapped. Generating that WMS for it's not straightforward. I mean, it's out there. There's a bunch of open source stuff out there. It's not exactly right. Surprisingly, it's not so straightforward. And there's actually things like that they gave the last where someone from Vermont showed how they took an NHL places where we tried to score the goal or something, and they generated a heat map, got a ring, and they uploaded it to us. I can do that too. The problem is, because you're like blowing up the you get the payload too large, so you actually see your edges and that's why you actually geo, because then like then you
So yeah, I was like, oh yeah, I'm not gonna have like, again, we just use
well, I mean, at least it's the standard.
That's I need to do this, get on the internet, and figure out the like externally. I like that, like, oh, this is awesome. You figure out that you try to interact with okay, so it's like, oh, we actually can't use that. We have an internal version of this, and I'll allow you to run it. So that's always a fun rabbit hole.
I'm wondering right. All the two times, then the box will sit back. Okay.
Yeah, so what is the intro? Yeah,
what part of the last?
And then we're trying to figure out how to do that to ensure our system. That's where just at play. You know, versus
Well, I saw the.
So you guys provide sort of the
Right after the screws, we provide Microservices. Well, we'll come out so that you guys trigger that it's going to be industry standard.
And so am I.
All right, so everyone who is watching the screencast, we're gonna get started with part 2. Okay, here we go. So I'll get everyone set up. So the mic is live, so we're live streaming right now. So.
All right, everyone. We're gonna get started with part 2. We have Barta from Confluent,
The creators, maintainers, and awesome people of Kafka. I'm gonna take her speech from her, so I'll let her take it away.
Thanks, Ben. So first of all, we are so happy and proud to be part of the inaugural Denver Data Engineers Meetup group. So cheers to Ben for organizing it and getting this group kicked off. Great job. We look forward from a Confluent Kafka perspective to a long and fruitful relationship with you as our buddies and friends as we move forward. I want to preface it by saying that I am not the original intended speaker, which means you have to be super extra nice to me. However, I am the local Confluent Kafka account manager for the entire Rockies area. So we're based here locally, just so that you know it. So those of you who are using Kafka in your companies or, just as interested in it, know that you've got local support here from our perspective. So what I'm going to do is, first of all, ask how many people are using Kafka or have used it. Okay, so that's pretty good. And then how many people have heard of our company Confluent? Yay! It's the same people. All right, that's good. That's good. So I'm kind of going to go over a little bit of Kafka and then some of the value add that Confluent provides over the Apache Kafka version. I'll also say that our Apache Kafka community is extremely important to Confluent. We helped, obviously our founders wrote Kafka, they created it, and so we're huge supporters of that community. From my perspective, I am building up this Apache Kafka community in this area. And you didn't know this when you walked in, but you're now also founding members of our Apache Kafka community. I've got another about 4 meetups that I'm scheduling. I'm going to ask Ben to help promote those as we go forward. And we'll do the same for you guys as well, for Astronomer. So let me kind of get into it. So how are people, like, why is Kafka important for a company? There's a lot of people out there who I call relational thinkers. And, this is the kind of situation the legacy relational database people are into. It's not their fault, right? They inherited, 10, 15, 20 years of, could have been 10 different CIOs. Somebody wanted to buy Oracle. Somebody else hated Oracle. They wanted SAP. Somebody else decided we need messaging. We'll get an ActiveMQ. And basically, over the years, this big, huge mess has built up, which creates a ton of challenges for organizations, right? The challenges, the themes of the challenges that our data is in silos, right? So we have a database team over here. We've got maybe now a big data team over here. We've got the development team over here creating APIs and stuff. We've got operations team over here. And you know what? None of us talk to each other. And this is my data. And they hug their pieces of data in their systems because nobody else can figure out what they've done or how they do it, right? So we're familiar with that. So how do we solve this big, huge mess, really? And this is where Kafka comes into play. So we try and get people to change and evolve their mindset from this relational batch thinking. Let's do some ETL, and we batch it overnight. Oh, that's been such a beautiful system for us, and it's been predictable. To capturing real-time data, getting real-time insights. The way we fix this whole big mess is by creating an event streaming platform, which is Apache Kafka. Okay, so this is at the core of it, and we like to call this the central nervous system for your company. So all of your different separate siloed crazy systems from the previous slide, they now integrate with Kafka, and basically you're consolidating it, into this event streaming platform. So again, you're moving from this batch thinking, relational database thinking into event streaming. And we believe that each piece of data tells a story. I was over here earlier and they're doing Denver data storytelling next door. So they said they might come over here later too. Because I said, that's perfect for us, for Kafka, because each piece of data is doing something. It has transactions, got interactions, and it's producing events. And then that's why you need Kafka to help capture that and manage it. And you've got your brokers, you've got consumers, producers, subscribers, right, that are generated out of Kafka. So some of you know our Confluent story. We came out of LinkedIn. What happened was our founders were working for LinkedIn, and they were trying to find a way to capture all these different messages that are coming at a extreme high rate of volume through the system. They tried out everything that was on the market, and they figured out nothing worked. Okay, nothing would do what they wanted it to do. So they came up, they coded the Kafka piece. And so obviously LinkedIn is, our very first reference case. But it is it's a huge company handling petabytes of data, trillions of messages. If a company like LinkedIn can rely on Kafka, I think there's no better story than that about why to trust Apache Kafka in your environment. And that's, we're born out of LinkedIn, but now we've got hundreds and hundreds of the, companies using Kafka, either in a development environment or in production. So we really are in production. Top two industries for us are financial use cases and also retail use cases. And some of the major reasons for that is trying to figure out what is the customer behavior doing online. And so how do we analyze that in real time? I mean, LinkedIn, sort of similar. They want to know who we are, what we're doing, what jobs we're interested in, and all about us, right? So they've gathered this information to develop a bigger picture on who we are as people. And that's what Kafka does, right? This slide is getting a bit dated because we have a lot more with the Fortune 500 and Fortune 2000 as the growth areas that a customer today. They're asking major growth areas. Telco is definitely huge for us, as well as the banks, travel. So it's anybody who really wants to be able to, first of all, we have a book, I think I ran out of them today, it's called I Love Logs, that was written by our CEO, Jay Krebs. Handling logs, managing logs, that's a major problem in every organization. We are at the core of that, being able to view what's happening, over the web, be able to detect any anomalies and create alerts. So CISOs love us in terms of doing fraud detection. So we have a lot, we have tons of use cases that you can use Kafka for. Huge adoption rate. I mean, our company's been around for about 4 years now, so I think this is amazing, the adoption rate that we've got. These are some of the companies that are using us, and you can see there's a wide swath, and everybody has thrown use case around it, but it's definitely creating a central nervous system for your data. I was at a customer today, and they're talking about our senior executives want us to have, machine learning and AI platform, right? And what they don't understand is we are nowhere near that because we haven't been able to put all of our data in one central spot, have it as, one golden record versus all these separate silos and serialness that they've got in their environment. Kafka is the platform that you put in, then you can build off of it, the machine learning, the AI, any future innovations and new projects. So here are some additional use cases for it. Somebody was asking me earlier, different use cases. Connected car, that's huge for us. Being able to handle sensor data, any high velocity streaming data, that's us. So we're definitely at the core of that. All of these, these are, every single company has one of these use cases at minimum, if not, 100 of them has been my experience. I've come from I've spent a lot of years selling big data ecosystems, and the number one thing with customers is how do we get to the utopia of real-time insights, right? That's the utopia. First, they're gathering data, storing it in Hadoop, but that's not the end game. The end game is getting to real time, and that's us. So if you want to do real-time insights and you're not checking out Kafka, I mean, you're missing out. So here starts the differences between Apache Kafka and then what Confluent builds on top of it. Obviously, we've got our clients, our connectors in the core open source system. I've given everybody these KSQL stickers. This is our latest open source enhancement to Apache Kafka. It allows you to do interactive SQL queries across data streams. And you do not have to be a Java, Python expert in order to be able to be a consumer of that data. So the number one business area in my mind that's key for is marketing. So marketing always wants to know what's happening with their customers. Right now, we need all the data, and they're always pressuring IT because IT is always behind with that. Well, now you can get to more of a self-service with marketing with the new KSQL over Apache Kafka. So we're super excited about it. It's super interesting. Every customer I talk to says, oh my God, we totally want to check that out. We just did a talk recently. It's online. I'm happy to send it to anybody about KSQL. We did a top 10 KSQL FAQs. So if you check out our confluent.io website, we've got a lot of talks that are coming up on that. We also have a ton of YouTube videos. So just go into YouTube, type in Confluent. You'll see all of our founders are on there giving talks, and some recent talks about KSQL and other reasons why to use Apache Kafka and Confluent. Way better than probably how I'm presenting this talk tonight. So I encourage you all to do that. On top of it, some of our value add that we've built is Replicator. So let's say you have a multi-tenant, multi-data centers, how do you replicate data between those? Well, we have a product for that, Replicator. A lot of customers will use that. And from a DR perspective, we also have auto data balancing that helps you, when like a cluster is starting to get overloaded, we can help to auto data balance that. And then something that's also really cool is every customer asks us, hey, how can we get better visibility? Do you have something that helps us monitor this data, provide triggers and alerts? Absolutely. We call it Confluent Control Center, or C3 for short, because there's 3 C's in it. And this is our monitoring tool, and it's super sexy. And every customer that we show it to really, really likes it. So if you're using Apache Kafka, you can download Control Center for free, I think for 30 days, and check it out yourself. So again, we always have that commitment to our open source community with everything we do. We try to keep things as open as possible. Okay, so this is just another continuation of that. We have our Kafka version. Then we also have our Confluent open source version. Everything we do in open source, we make available to our Apache Kafka community. And then we have our enterprise products, which include the control center monitoring, administration. We have additional security pieces, scalability, etc. This is another version of showing you the differences in the spreadsheet. I was with a customer today, and they wanted to reduce the licensing cost of a very well-known kind of #1 software provider, but it's very expensive. And so, we do offer JMS clients to help with some of those workloads and enhance security. We're very big on that. And I already covered some of these other things. But the #1 thing to think about is that when you're moving from a development environment and want to go into production, we are your best friends to be there available for you guys to make sure that production goes smooth. We could come out and, from a professional services standpoint, show you like, hey, let's tune it up here or there. We offer health checks and different services. Our SLAs are bar none. If people are calling us, typically we can fix an issue in under 10 minutes, which is, super, super great response time for anybody who's ever made a call into a, support ticket basis. All of our people who answer the calls, they are engineers, so we don't outsource that. You're getting a real engineer on the phone, And within a certain time period, if it is something that's been super complex, they can't solve it, it goes right to one of our Apache committers, like immediately. So that is super important to a lot of our customers, that they have true engineering support from us. So why would you look at using Confluent over Apache Kafka? We offer really fantastic training. It really goes a deep dive what Kafka is, all the underlying layers to Kafka. We have our platform pieces, professional services, the support. But moreover, companies are trusting us. We're very well trusted. We're enterprise. We offer a complete end-to-end solution. Our whole focus is Kafka. So that's what we care about. That's what we support. That's what we're moving forward with, whether on-prem, hybrid, or in the cloud. We do offer a cloud fully managed service as well. These are a lot of our founders and committers to Apache Kafka, based out of our Palo Alto headquarters. And then I have a couple other slides here. Anyway, so to give you an idea, if you were working for a company and they were interested in getting some additional training so that you can scale us out from an enterprise perspective, these are some of the things that we include, including best practices, writing the consumers and producers. I mean, this is very comprehensive training that we go through. Professional service. We are available. Our cloud is in AWS and Google, and then we have some other cloud providers as part of our roadmap. And these are just deeper into some of the use cases. This is confidential, so I don't know. Show that one. Sorry. Again, I put this together just 5 minutes before this, so sorry.
Marta's colleague Larry got sick last minute, so I think he'll be presenting at another meetup.
Another one, yes.
So,
he'd love to do another one.
But I appreciate you jumping in. So.
Yes, so I'll do the best I can. But the bottom line is Kafka has actually just been voted the #1 software that every engineer and developer wants to learn. So we're super excited about that. It's really hot. We have a huge community around that. Again, I'm trying to grow the community in this area. I need all the help of my founding members of the Apache Kafka group to please keep coming out and supporting us. We have a Slack channel for Kafka, for our open source community. I encourage you to feel free to join that. People ask questions. You can get a certain level of support from the Slack channel as well. And then there's myself and Larry, and I'm just Marta at confluent.io. So feel free to LinkedIn me or email me any questions. And the other thing is that if you're looking to have a career with Kafka, there are a lot of companies looking for Kafka people. So feel free to let me know that, and I'll try and hook you up with folks, with other major companies that would love to, to chat with you guys. So any questions for me?
Greg, I think, are we using Kafka, or I know Taylor's working with that in some way?
Yeah. We use Kinesis for some things right now on Amazon, but we're moving to Kafka. So it's like in development.
Okay. And that's a very common scenario that we run into. A lot of people have been using Kinesis and then are looking, for the Kafka support. And so, yeah, we're here for you. And it's very important to us, to support our community. So, definitely we are about open systems and, offering as much support as possible. Oh, the other thing I want to mention is we have started doing conferences. So we'll have a Apache Kafka Summit. It's coming up in San Francisco, October 16th and 17th. And right now we're in an early bird stage of that and for pricing. But then once that pricing is over, I have a discount code, which is just McLean 50. So if any of you are interested in attending, feel free to plug my code in. You have to wait till this early bird pricing is over. So we're looking for papers for that. People interested in speaking at it. You know, we want our community to come out and talk about your use cases. And so if that's something you're interested in doing, it's open for submission right now.
You mentioned there's a Slack channel. What's the Slack channel?
It should be just Kafka.
Kafka?
Yeah.
That's like, Kafka.
I will follow up with you on that.
Awesome.
Okay.
Just so I think.
I have it on my phone, so I'll just have to look at it. Sorry, go
How many
ahead.
employees at Kafka? How big?
So we are a privately held company, but our CEO has he has a blog about our growth. So right now, I think we're, we constantly hire, like it's almost like every 2 weeks they're introducing a new 20 people that we just hired. So right now I'm going to say 250 plus range. So it's a huge growth. I think over 400% growth from the other years, what he has on his blog.
And you said when's the IPO?
I'll watch out for that.
Yeah. Stay tuned. Stay tuned for that. Obviously can't comment on that, but stay tuned for that. So we're excited about the adoption though. We do a lot of philosophy search as well. And, this is where everybody wants to be. And, we need folks like yourselves, engineers like yourselves, to be part of it, be interested in it, help start playing around with it. It's free to download on your laptop, free to play around with, and there's a huge community that's based on it. So, sound good?
I guess
Yeah.
I've always heard, first, very well received. I've worked in lots of big data systems, Elasticsearch, Hadoop stuff. Kafka's always like, oh yeah, we use Kafka, it fixes all these problems. Cool. Always heard of message queuing, right? That's the whole thing I've always heard, message queuing,
Yes.
That's what Kafka does. And you're saying a lot of data streaming.
Yeah, messaging is just one piece. So messaging is just one piece of it. It started off with messaging. Okay, that was the story from LinkedIn, but it's expanded way beyond that. So it is about data streams with, now we put KSQL over data streaming, being able to monitor all your logs, your activity, what's going on. If there's an event, a trigger, something's happened, you get these alerts with the control center. You can also, it's used for data integration. Like if I went back to that second slide, that was more organized and showed, okay, you plug all your systems that were this big spaghetti ball, you straighten that out. It's like, we've organized your closet, and now you've got the data integration points into Kafka. So it's used for that as well. Yeah, the big catchphrase we like to call it is the central nervous system for your company. So it's the core of everything. It can act as the single source of truth and, of all your data streaming in. I didn't get into it, but something that you probably want to look at is also the schema registry piece of it that we have, which is really cool. It keeps that golden record organized.
Data streaming sounds more real time to me.
That's exactly it. Yeah, you've got it. It is about real-time data streams and being able to have insights across that data that's streaming through the environment in real time. So it's getting away from the old batch systems, that nightly batch. Customers, somebody I spoke to today said, they want access to the data that comes in within an hour. So that's our SLA now, and we're not meeting that. And as you guys know, that can be pretty scary when you're in an enterprise company and you're not meeting those SLAs. That's what Kafka addresses, and that was their reason for adopting Kafka in the first place. So definitely real-time data streaming So we've moved, messaging is still core, but we've definitely evolved beyond that. We're going to continue to evolve that. Yeah.
So I'm curious to know a little bit more about how the KSQL works with the rest of the ecosystem. Is it something that you, like what I write, like as a string, a SQL query in a streaming application, Kafka streaming application?
Yeah, it's not, it's called KSQL, but it's not the traditional SQL. So we put a K in front of SQL, and it's like this was literally, I found this out the other week why we called it KSQL. You know, so at any rate, you have Apache Kafka is this layer, right? And then data streams on top of it. Then KSQL is on top of the data streams, and it can query that data anytime, right? So anything that's happening, you're like, what's going on with this topic? It queries it immediately and gives you that information.
So like, what is the interface for that? Is that like, I'm still writing some query, whatever length, but is it in like the streaming application where I would write that and say, okay, run this topic through this KSQL query, or is it like a UI? I'm just curious as to like what that looks like.
Yeah, so you don't have to be a Java or Python programmer. So you're not like trying to like code the thing or whatever. It really, I don't want to say the wrong thing that has a GUI to it, because I think that is part of our roadmap is to have that GUI.
It's like a REST API right now.
Yeah, more in that area. Yeah. But I mean, you know, we have a lot of blogs on it on confluent.io website so that they can do deeper dive. And also, again, we've got some YouTube videos that are going to do a much better job answering your question than I am right now. So, but it is super cool. It's really, we're very excited about it because it is, everybody needs to know what's going on in my data at any given point of time, but you don't have to depend on IT necessarily to be providing those reports back to you, right? If I'm, you know, marketing analyst, I can do it myself and get that. So that's what's really cool about it.
You can try to like derive strings with it. So you query like outputs to another topic or something, you know, run a query on some input topics and then kind of string that out to output topics. It's really just, I think it's just an abstraction on the strings API.
Right.
It's like Spark SQL or something.
One of those ones.
All right, we are
Okay.
out of time.
Cool.
That's exactly.
All right. Thank you guys so much. Thanks, Ben.
Thanks everyone for coming. So you learned about batch and streaming tonight. Hopefully that was helpful. We'll be having the next one in about a month, hopefully. We're gonna, if anyone wants to present, maybe something on Elastic, we'll see. We're looking for presenters, but they're not gonna stop talking, so I'm going to.